Hello and welcome back. From the last video, there was one thing I forgot to set when we were setting up the sprite manager. One of the things that we need to do is the alloc block size. Because I am going to be using only 5 for the basketballs, I'm going to allocate this to 10. Basically, it has to do with how much memory or how much of the um, memory is allocated for arrays for storing the quads that the sprite manager creates. So you don't want to go too large with this because what will happen is it'll end up allocating too much memory that may or may not be used. But if you go too small with this number, it's going to be constantly reallocating blocks of memory, which could slow down performance. So go in, by all means, go into the wiki, read up on this, and get a better understanding on how to pick the numbers based on the number of objects or sprites that you're going to be having the sprite manager draw. And with that said, let's move on to the next part of this. What we need to do now is to get the sprite manager to actually draw something. So what we're going to do is we're going to come in here to the game manager. Let's go to the game manager script inside of Visual Studio, and we're going to set some more stuff up. One of the things that we need to do up here is we need another public method, or sorry, public field. And what we need to do is we need a sprite manager. So we're going to define a field called sprite manager of type sprite manager. And I'm going to use the lowercase s for this sprite manager. And that's going to create another field for us. And I'm going to save that. I'm going to jump back over here to Unity. And what that's done for us is under Game Manager, we now have a new field that's not allocated. But because we told it it's going to be of type sprite manager, we're going to drag our sprite manager into it. So now we've got our sprite manager associated with this sprite manager. Now from here we can go back into Visual Studio and continue on. Now from here what we need to do is we need a way of adding our game objects that are going to represent our sprites inside of Sprite Manager. So what I'm going to do is I'm going to copy this method and I'm going to duplicate it, and I'm going to rename it from add unity ball to add sm for Sprite Manager ball, and I'm going to keep the rest of this part the same. We don't need the rotation because if you remember, the unity ball is based on a plane which we had to rotate 270 degrees to face the camera. By default, all sprites that are created with the Sprite Manager are going to start off facing the camera, so we don't need to rotate it to achieve that effect. What we do have to do, though, is we have to tell the Sprite Manager to add a sprite for each game object that we pass into the add sm ball. To do that, what we do is we tell the Sprite Manager, the instance of the Sprite Manager that we passed in, to add a sprite. Now, from here, it's expecting a game object to be sent to it. So what we're going to do is we're going to cast in a game object, and that game object that we're going to cast in is the temp game object that we instantiated up here. The next thing it's looking for is going to be some information that deals with the texture that is applied to that sprite. Now, this initial float for width and the initial float for height that it's looking for is actually UV space. What it means is the texture has a UV space of 0 to 1. If we're using only part, or if we're using a texture atlas and we're only using part of that texture, we would use a smaller number than 1. But because our texture is our basketball and it only has that basketball on it, we're using all of that texture. So we're going to use the full UV space. So we're going to assign 1F and 1F for the UV height and width. Now the next thing it's looking for is the start position of our texture. Again, because we're using the whole texture, we're going to start our texture off at 0 and 0. And because we're using all of that texture, we need all of the texture's width and all of its height. And this particular texture that I brought in is 256 pixels by 256 pixels. So we're going to use all of that. Now, billboarding is referring to whether or not our sprite will always face the camera, no matter where the camera is pointed, whatever rotation, orientation, or position it's in. Because we're using an orthographic camera that's not going to move, and it's not going to rotate, and it's not going to move through our scene, we're not going to use billboarding, and we'll save some processing power by not having to calculate the billboarding part of it. From that, that's the only change we have to do. Now, if to look a little bit closer what's going on here is every time this add SM ball is called, we're creating a new game object called temp game object, and we're passing that into add sprite. What add sprite is doing is it's adding a quad into the sprite manager. The sprite manager is building a mesh when this script is being run. We are actually going to be calling this add SM ball inside of this loop, which means we're going to be calling it 5 times. So what this is doing is it's going to add 5 quads to the sprite manager, and it's going to combine those 5 quads into a single mesh. That single mesh will only need a single render call to draw all 5 of those sprites. So what I'm going to do is I'm going to take this and I'm going to replace this method with the add SM ball method, which is going to bring all instead of sending the functionality here, is going to send the functionality to the add SM, which is using our sprite manager to draw the sprites. So I'm going to save this code, and I'm going to jump back into Unity. We still have another thing that we have to change inside of Game Manager. We've added the sprite manager to it, but our ball prefab is still pointed back to our Unity, our ball Unity prefab. And since we're doing the sprite manager, we need to bring in our other prefab. So now we've got everything all set up. There doesn't seem to be any errors. And if everything works out right and I hit play, we should see some basketballs. Now, what's going to be weird is, depending on how close you are paying attention to the videos, they may not react the way you think. In other words, they're not going to fall, and they're not going to bounce, and they're not going to have any physics applied to them. And if you remember, that's because we're using the sprite manager for our sprite manager and not the link sprite manager. And as I said in an earlier video, the sprite manager by default is not going to update the position of the sprites based on their associated game objects unless we explicitly tell it to. So what's going to happen is the sprites are going to be drawn in their initial position, and then they're just going to stay there. But the game objects that are going to be created are going to continue to fall and rotate and act the way you would expect. But now that I'm thinking about it, there's something we forgot that we have in our Unity prefab that we don't have in our our ball SM prefab, which is this configurable joint. And if you remember, the configurable joint is used for constraining the motion in depth. It's used for a lot of other things, but we're using it specifically for constraining the Z motion. So I'm going to go in here real quick. I'm going to set that to locked, and then I'm going to configure it in world space so it holds in depth like we expect it to. So I'm going to save those changes and see what we get when we play. So like I said, I hit play and then I just paused it. But what I want to do is I want to select all of these prefabs. And I'm going to zoom in here a little bit. Let's move this over. What you can see, that's a little bit weird. And if you look closely, what you can see is we've got our sprites, which our sprite manager is drawing. And then we've got all of these sphere colliders that are moving. Now, if I unpause this and let the simulation run, you can see that all of our sphere colliders are acting the way we thought the simulation should. But all of our sprites are stuck up here. Now, why is that? The reason is actually because we're using the sprite manager, not the link sprite manager. Here's something that's kind of neat. If you click on the sprite manager, you'll see we get a transform. Now this transform is at the world Z, but it's also associated with these sprites. And if I move it, all the sprites move along with it. And the reason why is the sprite manager is associated with a mesh, and you can see it here. It's added its own sprite manager mesh filter and its own mesh renderer. This only happens at runtime. So what has happened is inside of the game manager, when we loop through that add SM ball method, and we've called sprite manager.add sprite, it's added a quad for each one of these basketballs. It's then merged all of those quads into a single mesh, which is this sprite manager mesh, and that is what it's drawing. Now, what the sprite manager does is it renders it based on those vertice positions. But because we're not using the linked manager and we haven't told it to check for changes, it's not updating the positions of those quads in relation to our objects. Now, to fix that, what we're going to have to do is go back and tell it to do it manually. And I'm going to show you how to do that right now. We're going to jump back into Visual Studio, and then we're going to come down here, actually up here to the update function. Now what we're going to do is I'm going to copy this for loop up here, and I'm going to bring it down here, and I'm going to paste it. But I'm not going to call the add SM ball because that would just create 5 more instances every frame. We really don't want that to happen. What we do want to happen though is we want our position for each one of these balls to update. But how are we going to do that? Well, if you look at the sprite manager and add sprite method actually will return a sprite. And that sprite is actually a reference to, in our case, one of those basketballs. So what we have to do now is we need to add a structure, or sorry, not so much a structure, but a data structure to hold that. So what we're going to do is we're going to create another array list, and we're going to name it sprites. And we're going to initialize it. Now we're going to populate it. We're going to come down here, and what we've done is where we've added our temp geo, we need to do something similar with our sprite. So to do it, what I'm going to do is I'm just going to type in sprites and dot add, and what I'm going to do is I'm going to pass in this entire line of code. So what this line of code is doing is it's going to add the sprite manager, or add a sprite to the sprite manager that is then going to return a sprite from this method, which is then going to be added to our sprites data structure. From there, I can come back up here to our update, and instead of doing add SM ball, I can do sprites dot let's see, what is it? It's sprites. Sorry, my bad. Sprites dot I dot let's see. Oh, I gotta cast it. what it's doing is it's not sure because it's just an array of objects. It doesn't know what type of object. So I have to cast the sprites array, or this particular instance of this array, to a sprite, which should then allow me to update. And you would think it would. What did I miss? Oh, my bad. I'm thinking of it the wrong way. Close, but not exactly. I need to call the sprite manager, and I have to tell it to transform, and then I have to pass in the sprite that I want it to transform. So from here, what I need to do is cast to type of sprite, and I have to pass in my sprites, the current instance, which is going to be sub I. So now what I'm doing is I'm telling it to loop through all 5 and get that sprite, cast it as type sprite instead of an object, and then transform it via the sprite manager. So what's going to happen is every frame, the sprite manager is going to update all of its sprites based on the associated game object that we sent it. So I'm going to save that, and if everything worked right, and I hope it did, I hit play, and our basketballs are going to react the way that we expect them to. And I've got an error. Sprite could not be found or missing. So what did I do? Something in the cast. Let's see if it works without it. Nope, definitely wants me to cast it. Cannot convert from object to sprite. So let me see what's going on here. And may very well be it wants me to cast this as a sprite as well. So let me try that. You'll find that with Unity there's a lot of casting to enforce types. And still missing directive or an assembly reference. Give me a sec while I figure this out. Trying to figure out exactly why it does not see. Let's see what is going on here. Alright, let's see. Oh, I see it. Typo. I fat fingered it. Actually, it needs to be sprite. That will probably make it a little bit easier. Alright, let's save that and see what's going on. Alright, so now that errors, listen. This error, don't have to worry about it. It's because we're actually still running the simulation. Alright, so go ahead and run. And as you can see, now it's updating relative to all the cloned prefabs. So it works the way we expect it to. Alright, so let's pause or stop that animation. And basically, that's all I really wanted to show you with this video is basically what happens when we use a sprite manager, what is actually going on, how the sprite manager is creating the sprites, and how they're associated with the sprite manager. And then the fact that if it's just the straight sprite manager, you're responsible for determining what sprites are moving and make sure that their positions are updated via the transform method call inside of the sprite manager. In the next video, I'll be going over how to get the link sprite manager working and the code needed for that. See you next time.